All right, so as I was saying just now, what comes to your mind when you hear the word distributive?
Share.
Yeah, go ahead, Miss Cummings.
To share.
To share. Anybody else? Anybody else have any other thought in mind when you hear the commutative law? Sorry, not the commutative, the distributive law. Or the word distributive. Miss Green, are you with us?
Yes, sir. Yes, sir.
When you hear the word distributive, what comes to your mind? What comes to your mind, Miss Green, when you hear the word distributive? Not ringing a bell at all, Miss Green.
I'm thinking about it, sir.
All right. So while you're thinking, let me ask Mr. Arjano. What do you think, Mr. Arjano, when you hear the word distributive?
I think to give something.
What?
I think to give something.
To give something. So if you're in like a kind of a hurricane shelter and you have some supplies and they say distribute the supplies, what you're generally going to do?
I will group them in sets and give to the people.
Right. So you're going to give out the supply, but in distribution, what you find that each of the individual would actually get something, right? Agree?
Yes, sir. They would get a specific amount.
Right. So distributive really means giving out. And so in giving out, in mathematics, we have a law known as the distributive law, which we are going to be looking at now. And this is what the law states. Now read the law first and then tell me what you think it is saying. So I'm going to ask Miss Scott to read the law for us. You can do that, Miss Scott?
Yes, sir.
All right, go ahead.
Multiplication is distribute over addition for a set of numbers.
All right. So it's a multiplication is distributive over addition for a set of numbers. What comes to your mind now about this law? What do you think this law is really saying? Seems confusing? All right, now suppose let me put this down here now. And look at what is happening here and tell me what you think the law is saying now.
It's showing that instead of you using addition, you would use multiplication.
All right. Ms. Green, any thoughts about what is happening here?
So it's a bit confusing. Can you explain a little more?
Will.
So,
Miss Cummins, you want to add something here?
Yes, sir. So instead of to add B plus C, then multiply by A, you will multiply A times B, and then add A times C.
Okay. All right, good point, Miss Cummins. Anybody else want to share their views? What about you, Miss Waysam?
Sir, A is shared with whatever is in the bracket. Just as Miss Cummings had said. The A and the outside is shared whatever is inside the bracket.
All right. I don't know if it is share that you really want to say, but look at what the law states and then see if it gets clearer in your mind. Multiplication is distributive over addition for a set of numbers. Is it any clearer to you? No? The screen? Still have you thinking?
Yes, sir. I'm understanding it now, sir.
Say that again, Miss Green.
I am understanding now, sir.
Are you understanding? All right, tell us or tell me what you're understanding so far.
So when you they have the number that's on the outside, you times it with the numbers in the bracket, and then add the letter, and then it will be added to them.
Okay. Now in the law, how many different types of operation you're identifying? What are the operations that the law talks about?
Multiplication and addition.
Addition, right. Now, where in this bracket situation would you have multiplication? One of the rules in mathematics is that if you group things together, for instance, you group A and B, if you group letters together, there's always an invisible multiplication sign between them. Now, they don't really write the multiplication between them because it would probably let it look too crowded when you write it with multiplication. So it's just for ease of, or for clarification to kind of keep out the multiplication when you're working in algebra with letters. We say that once you have them grouped together, there's an invisible multiplication sign between them. Now, it doesn't only work with letters, but it also works with brackets. So if you have a bracket grouping with something, there's an invisible multiplication sign between the bracket and that thing. Is that clear to everyone? Now, so if the multiplication is here, so it's a multiplication is distributed over addition of a set of numbers. Now the set would be the group. So the set is what is in the brackets. And the A is outside the brackets and it is multiplying the bracket. So the multiplication process has to be done in a distributive way. So when you're multiplying what you have in the brackets, you multiply distributively by using the A, like you're distributing the A. So you give a A to the B, and then you multiply. Then you give a A now to the C and multiply. Now, when we do the first distribution, so we distribute the A times the B, we get AB. Now we keep back the sign before we do the other multiplication. So now we have, we distribute now the A again to C. So we say A times C, we get AC. And so this is what the distributive law is really saying. When you're multiplying what is outside the bracket by what is inside the bracket, you multiply each of what is in the bracket by what is outside. That's all it is saying. Each of what is in the bracket you multiply by what is outside. So each term, so you multiply the B times the A, then you multiply the C times the A, and that's how we get A, B, and plus a AC. And it doesn't just work for this bracket, but any bracketed situation, it works in that sense. So if you have, say, for instance, 3 brackets, x plus 2, what would be the answer here when you multiply out? Anybody?
3x plus 6, sir.
Right, so we're going to take the 3 times the x, we get 3x. Then we bring back the addition symbol. And then now we,
Oh, that line answer.
and then now was it, hello? Was that question directing to me?
Sorry about that, sir.
Okay. Now you're going to say 3 times 2. So you get 3 times 2 equal to 6. And so once you have multiplied out the bracket, this is the result that you get by multiplying 3 times the bracket. Another thing you could say, this is the what? The product. Because remember the product is the result you get from multiplying 2 or more things together, or 2 or more factors. In this case, what are the 2 factors being multiplied here? Can anybody tell me? On the left-hand side here of the equation, we have 3 times bracket x plus 2. What are the factors in the multiplication?
X and 2, sir.
Say that again, Miss Cummins.
X and 2.
X and 2 will be the 2 factors being multiplied. All right, in a sense,
Yes,
in a sense,
sir.
in a sense, you're correct. But when you're doing the distributive law, actually you're multiplying each of what is in the bracket. But in terms of what we have an expression here, before we multiply it, we would have 3. Remember, there's an invisible multiplication sign between the 3 and the brackets. So you would have times, then you have bracket x plus 2. So when you look at this, what 2 things are being multiplied?
The 3 and the x plus 2 in the bracket, sir.
Right, so the 3 and the brackets, which is a set. Everybody see that? So those are the 2 factors. So when you multiply 1 factor 3 times x plus 2, which is another factor. Now, when we group things in brackets, the group is considered to be singular. So bracket makes a group of things become singular. So you can treat the bracket as a single unit. So you are multiplying 3 times the bracket, which is x plus 2, as a single unit. Is that clear, guys? Now, when you're multiplying it out using the distributive law, then you're just following the rule of giving out a 3 to each term while you're multiplying in the brackets. Now, the distributive law is not the only way that we can work these problems, but it is one of the ways that we can work the problem. So the distributive law is a law that you should be familiar with. All right. Any questions, guys? Now, let me look at another one. Suppose I have 3 brackets 2A, oh, that's supposed to be A, oops, 2A plus 4B plus 6C. What would be the answer here? I'm going to call on individuals. So this is 2A, this is 4B, this is 6C. Miss Scott, would you like to tell us what the product of this when you multiply 3 times this set of, what I must say, the set of terms, what you will get for the product? Ms. Scott, are you there?
Yes, sir.
Okay. I'm not hearing exactly what you're saying though. Mr. Ojeno, you want to?
The answer would be 6A plus 12B plus 18C
Plus 12B
plus 18C.
plus 18C. Anybody agree with Mr. Ojeno? Raise your hand for me, please. All right. Miss Scott. Miss Scott, do you see how Mr. Ojeno arrived at his answer?
Yes, sir.
Was that a yes?
Yes, sir.
Okay, good. All right, so those are examples of how to use the distributive law. All right, so we say that multiplication is distributive over addition for a set of numbers, and the set would be generally the things in brackets. And it could be, you might have addition, subtraction in the brackets. So what you generally have in the bracket, we generally call it an expression, all right? Later on, I'm going to give more clarity to what expressions and terms are. Now, we say that if for unknowns A, B, and C, if A times bracket B plus C is equal to AB plus AC, then A is distributive over the addition of B and C. All right, so that's all the distributive law is saying. Now, if you have done brackets anytime at all with math, and you have to multiply out brackets, you would have been using the distributive law. All right, now moving on. Now we're going to be looking at identities. Now in mathematics, we have two identities. One we call the additive identity, and the other one we call the multiplicative identity. When you hear the word additive, what comes to your mind? Anybody?
Add it, sir.
Add. So additive suggests that you're adding. And if I say multiplicative, what would come to your mind?
Multiply.
Multiplying, right. Now, there's a number that we call the additive identity. And the number we call the additive identity is 0. 0 is called the additive identity. Now, anybody know why 0 is called the additive identity?
Yes, sir. For example, any number that you add 0 to, you get back the same number.
Right. So the operation that we're doing, we're adding the 0. And when we add the 0 to any number, we get back the number that we added to. And because of that, we say 0 is the additive identity. So my question to you is, what would be the multiplicative identity? Which number?
1,
One,
sir.
sir.
1. Because if you use 1 to multiply any number, you will get back that number. All right? So for that reason, these numbers, we call one additive identity, the 0 because we are using the operation adding, and 1 is called a multiplicative identity because when we are multiplying any number by 1, we get back that number, all right? As you can see from the examples. All right, any question, guys? Everybody clear on what identities are? Are we clear on what the 3 operation laws are? We know we have commutative law, and we have the associative law, and we have the distributive law. We have additive identity, which is 0, multiplicative identity, which is 1. And we should know why we call these additive identity, why we call the other one multiplicative identity. Now, we're now looking at the multiplicative property of 0. One of the things we know is that when we multiply any number by 0, what we get?
0.
Any number we multiply by 0, we get?
0.
0. Everybody agree with that? Let me see the hands of those who are in agreement. All right, good. Seem like some of you have doubts. Now, that's a property of 0 that if any number is multiplied by 0, the result is 0. So that is a property of 0. We call it the multiplicative property of 0. Now, it only works if we are multiplying. Now, if we add 0 to a number, we don't get 0. Right? So that's why it's a multiplicative property. Works when we are multiplying. So here the example, 19 times 0 give you 0, or 0 times 237 will also give you 0. Any questions? Clear as crystal or as mud? Raise your hand, guys, if it is clear what I'm saying to you, so we can move on. Everybody is good? All right, great. All right, moving on now. The next property, dividing by 0. Now, dividing by 0 in math creates a problem. Can anybody tell us why dividing by 0 creates a problem?
So because you will be dividing nothing.
You'll be dividing nothing. Is it that you'll be dividing nothing, or you'll be dividing by nothing? Which one of them?
By nothing, sir.
All right, what kind of problem do you think that would create for us now? Anybody? The screen? Why would we say that dividing by 0 is a problem?
Sir, the fact that you don't have anything, any numbers to divide it by.
Let me ask you a question. Suppose
Yes,
I
sir.
have 0 divided by 3. What would be the answer?
Sir, 0 divided by 3, so you don't have anything to divide it by. You're dividing the 3 by nothing.
All right, anybody else have anything to say about this?
Sir, it would be impossible.
That would be impossible. Anybody else have anything to say about it? So, Jana, do you want to share your views? Not hearing from Miss Argino. Miss Argino, not sure. All right, what about you, Miss Amanda? Do you want to add anything?
No, sir.
I realize Miss Chabelle, okay, Miss Chabelle is here. You agree with that, Miss Chabelle? Or was it you who said that? Miss Waysome, would you like to share something?
No, sir.
No. All right. Now, before I move on, what is really happening here for this situation? What is dividing by what? In this case, which of the number is the divisor and which of the number is the dividend?
Sir, 3 would be the divisor and 0 the dividend.
So in this case, we are dividing by 3, right? Now, if we are dividing by 0, we would have what? 3 divided by 0. Now, are these two the same?
No.
All right, what would you get if you divide 3 by 0? What would be the answer?
You would get nothing, sir, because I can't divide 0 by 3.
I'm talking about this one. If you're dividing 3 by 0, you'll get what?
You get back the same 3.
All right, so you say you get back 3. Let me see the answer those who agree with Ms. Waysam. All right, Ms. Ashanti. Who else? Ms. Green. Who else? Ms. Scott. I never hear the saying one fool make many. Never hear that saying?
So you can't be fool.
One fool make many. All right. I'm just referring to this saying because I know sometimes people will accept someone else's answer, not because it is their own view, because they just feel like whatever the person is saying is correct. But sometimes you really need to think about what the question is about or the problem is about before you really jump to a conclusion. So this would be wrong. So you would not get 3. Now, what I want you to do for me, if you are able to access your calculator, divide 3 by 0 and tell me what the answer you get. So you're dividing 3 by 0.
Error, sir.
Error. Anybody else? Anybody else get an answer? Miss
It says 3 can't divide by 0.
can't divide by 0. Miss Amanda? You tried? What about you, Mr. Ojeno? Have you tried it?
Calculator showing invalid.
What is it saying?
It's showing invalid.
Invalid. Now, based on all your calculator, that is saying something. We cannot divide by 0, students. We cannot divide by 0. And when you really think about it, what is really logical about it? Go ahead, Miss Waysam.
All right, sir, just to clear the air for me so I can get a better understanding. So it doesn't matter whether 0 is in the numerator or in the denominator, no matter how you try to divide 0, just go get back 0. 0. Point blank, 0.
No, that's the case, you know. It appears that way, but that's not the case. So that's why I really write these things, so to somewhat make you think about them, because the two are not the same. They are two different things. What do you think the answer for the one above here should be?
0, sir.
Try to the calculator and see what you get.
Zero, sir.
Anybody else try the top from this way, son? It's coming. You tried it? I'm waiting on at least one other person to give me what they get.
0, sir.
You get what? 0? So this one is actually 0. Now this one, the calculator said there's an error. So whereas this one is okay, what is happening with this one?
It's an error.
And why do you think we have an error? What is it that is not logical about it? Why do you think
0 cannot, because 0 cannot use to divide any number, sir.
But why? Remember, I said to you that you have 3 criteria in math. You have knowledge, comprehension, which is understanding, and reasoning. Those are the 3 things that they're asking you for. Now, when you're talking about reasoning, you have to say why. So why is it an error to divide by 0?
Because it holds no value, sir.
All right, yes, that is kind of obvious. You're not going to get any value, but in a practical sense, if you think of it in a physical sense, 0 is a space where you have nothing at all, emptiness, right?
Yes, sir.
Now, if you consider that you have 12 and you're dividing 12 by 4, what would be the answer?
3, sir.
3, right? Now, when you divide 12 by 4, what is it that you're doing, really?
When you're what, sir?
When you divide 12 by 4, what you're doing with the number?
Seeing how many times they can actually get 4 out of 12.
All right, let us think of it in a more practical way. Suppose I have 12 mangoes. and I'm dividing it for 4 people, what would happen? How much each person would get?
3 each, sir.
3 each. So we are dividing 12 things into what? 4 parts of 3s. You follow?
Yes, sir.
Now, when you think about dividing 3 by 0, you are dividing 3 into what? How many parts you really can divide? What are you saying? You are trying to divide 3 into how many parts?
In parts of zeros.
Right, because you see, that is a problem, because 0, to say you're breaking the things into parts, you're trying to break 3 into empty parts. Now, 3 is something and 0 is nothing. So in other words, you're trying to divide up something into nothing, and that's not possible. You cannot divide something into nothing. It is impossible to do. And so because of that, we call it an error. Is that clear, guys? Do you understand exactly what I'm saying now, Miss Green?
Could you go over the last one, sir?
Right. So if we have 20 mangoes and we divide it into 4 sharing it for 4 people, we divide it equally into 4 parts. So we divide the 20 into 4 equal parts, which would give us, each part would have 5. Now, when you divide 20 now by 0, how much each part going to have? If you try to divide 20 by 0, how many parts you're going to divide it up into? Can you divide it up into 0 parts?
No, sir.
No, impossible to do. So in math, we always say that that is meaningless, or it is undefined, because in math, we really don't have a meaning for it. So it is impossible to divide by 0. Hence, a number divided by 0 is meaningless or undefined. But on the other hand, 0 divided by a number would not be meaningless. Now, if you think of it in that way now, suppose we have 0 divided by 20. So now we have 0 divided by 20.